All right, welcome to the last part for recursive rules before we get into word problems. I'm on page 444, numbers 9 through 12, but I did copy down the core concept that was on page 442, so I suggest you do it again. Remember, you don't need to memorize things. The more you write it, the more you know it. The next, for arithmetic sequences that are recursive, the next number is the previous number plus the common difference. Remember, we also need to define the beginning term. For geometric, the next number is the common ratio times the previous number. All right, and then if you think back to 8-2 and 8-3, if it's an arithmetic sequence, now remember we prettied this up, but the next number is the first number, first term, plus n minus 1 times the common difference, right? This was our slope. It looked like a slope. And then finally, if it was geometric, the next number is the first term times the common ratio, which is our base, to the exponent n minus 1. Common ratio is our base. Okay, so let's, for number 9 on page 444, it says to write a recursive rule for the sequence. So the next term is 17 take away 4n. All right, well, I want to identify, first of all, what type of equation is this? Well, actually, it looks like it's an arithmetic equation. All right, this is the explicit rule because it's asking me for the recursive rule. So I need to figure out what is a sub 1, and then I need to figure out how to write it as something. So first off, I actually can tell you, well, let's just do a sub 1. A sub 1, we're going to plug in 1. So 17 take away 4 times 1. 4 times 1 is 4, 17 take away 4, so a sub 1 is 13. Okay, and then this is our common difference in an arithmetic sequence. It's the slope, right? It's being multiplied to our variable. Remember, we had to combine like terms somewhere. And our common difference is being added out to the back of our recursive rule. So if I can identify the common difference, I can just write it down. Well, here's our common difference, negative 4. It's the slope being multiplied to n. So I'm just going to drag that down and write minus 4. So here is my recursive rule. Always start with the beginning term. The first term is 13. How did I get it? I plugged in 1. The next term is the previous term plus the common difference, in this case, minus 4. Okay, let's take a look at number 10. All right, the explicit formula tells us that the next term is 16 times 3 to the n minus 1. Sorry, the nth term. Well, I know that this is a sub 1, and I know that this is my common ratio, so let's start out. The first term is 16, and for a geometric recursive rule, the next term is the common ratio times the previous term. So in other words, the next term is going to be 3 times 16. There we go. All right. So once you can identify which parts you're using from the explicit rule is what we learned in 8.2 or 8.3, then you can just plug it in where you need to. Don't forget, you always need to start with your first term. Okay, now can we go backwards? Can we write an explicit rule for a recursive rule such as the first term is negative 12, and the next term is the previous term plus 16. All right, well, I know that this is my common difference. Okay, and I know that the explicit rule for a formula is the nth term is the first term plus n minus 1 times the common difference. All right, so the nth term is the first term plus n minus 1 times 16. Let's distribute the 16. I get negative 12 plus 16n, take away 16, that is a 1. I know it's pretty ugly. Let's combine like terms. 16n, take away 28. So here we go. Here's my explicit rule. The nth term is 16 times n, take away 28. All right, identify your common difference, know which formula to use, plug in what you have, and then simplify. All right, let's see if that works out for number 12. First term is 2. The next term is negative 6 times the previous term. All right, so this looks like it's a geometric sequence. And my explicit geometric formula is the nth term is the first term times the common ratio to the n minus 1. All right, well, they tell us what the first term is. So the nth term is 2. What's my common ratio? Though that's out front, times negative 6 to the n minus 1. There we go. That's all we got to do. We identified that it was geometric from here. We know that this is our common ratio, this is our first term, and then in the explicit formula, it's the nth term is the first term times the common ratio as your base to the n minus 1 power. All right, you have problems to try. We'll get a chance to catch up soon. All right, so do your best.